This is a talk that's sort of based on some of the work that our team has done over the last year. We took ownership of a system at Flatiron that has been around for a while, is very critical, realized there were a bunch of challenges in getting it to do the things we wanted to do, and came up with a plan to get to a happy end state. So we're going to talk about what happened during the process. Cool. So as Sam said, we are engineers at Flatiron Health. I've been at Flatiron for about 3.5 years. Marius has been there for about 2.5?
Pretty much.
Something like that. We've both been on a variety of different things during our tenure at Flatiron. Now we work together on a team that is responsible for building data tooling. So our team builds tools and libraries that are used by other engineers at Flatiron to work with the data that we are generating. So in the beginning, as I mentioned, we inherited a system that had been around at Flatiron for a while. So it's Flatiron's primary data pipeline application system. It was written in the early days of the company. For context, the company is about, I don't know, I want to say a little over 6 years old.
6, 7.
Maybe 7. Time flies, who knows. And it's used as a system through which we write our data products. So at Flatiron, we build a lot of data products, which we sell. During the early days of the company, we realized that we needed a system that could do a variety of different things, which we'll cover. There was nothing really out there that met all of the needs. So like engineers everywhere, we said, let's build it ourselves. So when we created the team that we're on now, data tooling, about 1.5 years ago, we sort of got voluntold to own this magnificent system, as often happens. And so as we took ownership of it, we had to do a lot of discovery to realize, okay, so now we own this thing, which is very important. What does that really mean for us as engineers on this team? So what have you adopted? Yeah. So as I mentioned, it's sort of a very core system to Flatiron. It's used for building most, if not all, of the data sets that we as a company generate and sell, which means it's extremely mission critical. It's also extremely stable, which is to say that the system was authored, as I mentioned, during the early days. There's been obviously a lot of development that's happened over the years, but for the most part, it's not something that has breaking changes all the time. The changes that it has are very minimal. There's a few engineers at the company who really understand it and make changes to it, but by and large, it's a system that, since it was authored, has been more or less in a very good, stable state. It's made up of a lot of dark magic voodoo, let's say. So the innards are a very complicated mishmash of Bash, Make, Python, C, all the fun technologies that, of course, everyone is super familiar with all the time, right? And as I said, so if you are working within Flatiron, you're probably going to use the system if you're on our research side of the company, which builds data products. And as you get started, you realize that really the only way that you're really going to learn the system is by working on the system. It's super critical, but hey, that doesn't mean you have great docs around it, right? So people have developed patterns and workflows. We have onboarding sessions which have you follow example pipelines that you can build to sort of understand the system here and there, but really it's not a great experience, and typically engineers who start working on it spend, let's say, roughly about a quarter before they feel like I kind of understand what's going on here and I can have a mental model of what I'm about to do with a change, which is still wrong half the time. So yeah. And also, as I mentioned, it's super critical, which means that there's a lot of people who use it, which means there's a lot of people who want things from it that are not in it right now, right? It's a system that's used by hundreds of engineers. It's not going to be perfect for everyone. So there's a lot of feature requests that are always outstanding in it. There's people who make contributions to it here and there. And it also means that those people are very protective of the code. So if you have spent a long time understanding a very complicated system and feeling like you've climbed that summit and someone wants to come and sort of change it out underneath you, you're probably going to react to it in a not happy way because you feel like, I put in the effort to do this, you should too. So if you're going to make changes to it, I have opinions, as is often the case. So it's very black box. The engineers who understand it have devoted many, many hours getting to that point. And unfortunately, none of those engineers are on the team that took ownership of the system, which is, great decisions all around. So it's used to power all of our data stuff, which means at this point, as the company has grown, there's, let's say, roughly tens of thousands of files that are built within this ecosystem. So it's not something that is trivial to sort of iterate on or change. And as I mentioned, when we built it because there was really nothing that did all the things that we needed to do. I'll specify some of the things just for context. So it's used for versioning, reproducibility of data. So if you're building a data set as a healthcare company, it's very important for us to be able to prove that whatever data we built was built in a way where you can look at the snapshot of the data. It subsequently leads into having provenance around the data that you're working with and building. It's a very flexible system in that you can write your pipelines in really any language so long as you support the interface that is used for building the data set. So everything comes in as a CSV, everything goes out as a CSV. We're trying to change that, but let's get into that later. And it's the workflow orchestration system as well. So you write a bunch of your nodes for your pipeline, and then this thing can understand how to build your DAG and run it for you as well. So it does a variety of different things, and now there's tools on the market that are very mature that do some, if not all of the things, but for our needs when we started, nothing met all the checkboxes, so here we are. Cool, so now you own the system, it's very critical. You kind of understand what you've gotten yourself into. Where do we go from here? So as you start to talk about, all right, I own the system, I want to make changes to it, you first have to figure out what are the things that you want to be doing, and should you even do anything at all. So Flatiron has a bunch of values which are very important for us. They're taught to every new employee who starts, and people are sort of encouraged to espouse them during their day-to-day lives. And one of those values is start with why. If you're about to do something or someone else is about to do something, it's a good idea to ask, all right, why should we do this? Why is this important? Why are we spending this time, manpower, money to do whatever you're proposing that we should do? So you've taken ownership of a legacy system. Now, should you even do a migration to make it modern, right? What would you gain if you did this? And there's two parts to that, right? What do you gain as a maintainer? And what do people gain as users? What is the onus for making any changes to this supposedly stable system if it's legacy, right? Is it going to make the lives of people who are maintaining it easier? Are people going to start seeing some new capabilities that didn't exist in the system? Or is it going to be bells and whistles that you're planning on adding, which would require, say, quarters of your time to do, but people don't really care about it, or it doesn't really unlock any new business capabilities? Assuming you figure out all of those questions and you come up with answers that lead you down the path of we need to do something with the system, you have to figure out, all right, so how do we want to get to whatever the future looks like? There's always a few different options that you can take, right? You can always build or buy. So you have a system, there's things you want it to do. Maybe as we discussed, right, when we started, there was nothing on the market that did all the things that we wanted to do. That was 6-7 years ago. Maybe that's not true anymore. So as you're about to embark on maybe making changes to a very legacy system, maybe it's a good time to reevaluate, is there even a point in us doing anything? Do we rebuild it from scratch? Do we abandon the system altogether and decide what we want the good end state to look like and just spend the time building it from scratch so that we don't have to deal with understanding a bunch of legacy code and doing the work to bring it to modern state instead of just starting from clean blank new state where you can write Pi 3.8 code from scratch and not have to deal with Pi 2.7 or God forbid 2.6. Or do you not build it at all and you just go out into the market, pay someone a bunch of money, buy something that they've already built and make it someone else's problem, right? Also a perfectly viable path. It might be cheaper for the organization to just pay someone money to get a system and get vendor support from it as well, instead of spending time and engineering efforts into building something yourself that really at best replicates something that's already community standard. Yeah? So let's say you don't do that. Let's say you go down the path of modernizing your system. So you're going to put in a lot of effort and give it tender loving care to make it into a modern system. We'll talk more about that as we get along because, as you may have gathered, that's kind of the point of this talk. Or you do nothing at all, right? As we said, it's stable, it meets the needs of most of the people who are working for your company, it does what it was intended to do, and people are still able to develop and provide value to the business from it, maybe you shouldn't do anything at all, right? One of the things that we thought or found useful to ask was, great, let's say we don't want to do anything. Would we be happy as maintainers of the system if we did nothing? Would it be something that would then lead engineers on the team to burn out as they're trying to fight with legacy code as random bugs happen here or there? Are people still going to enjoy working on the system, or are they going to feel like, what am I doing here? What is the point of me being on this team, maintaining the system that's not really under my control to change? Maybe I should be doing something else with my time altogether. Cool. So we evaluated our options and we said, we're going to modernize this thing. We're going to change what it looks like. Great. So as you start doing that, you have to paint the picture of what are you trying to accomplish here, right? So the first thing you should figure out is, what are people doing with the system that you've just taken ownership of, right? There's always the intended use case for a system. Developers write something and say, all right, this is the problem that I'm trying to solve with this thing. If you have this problem, great, come along and do this. Over time, users always find very creative ways to do things that engineers never think of. Engineers find really creative ways to do things engineers never think of. And maybe the actual pattern that is being followed by your users is not what was intended by the developers. And you come and take ownership of the system, you read through it, you understand, all right, this thing is meant to solve use cases A, B, and C. What are these people who are doing X, Y, and Z? No, I'm not going to support that. I'm going to cut you off right there. Great. Now you have a bunch of very unhappy users who are not going to trust you whenever you make any changes and are just going to go and find something else because, what are you doing not supporting this thing? You can't just point fingers and say, this system was not intended to do this if for the past several years people have been doing something else altogether. At some point, that is the intended purpose of your system. It doesn't matter what the original intent or what the words written in a document are. Nothing is set in stone, right? So patching hacks that provide functionality to users is never a good idea. You have to have the empathy for your users to say, all right, maybe this was not intended to be the thing that you should do, but you're doing it. Now it's a thing that we're going to have to support. You figure that out, great. Now figure out, what do you want the end state to look like? You modernize the system. At what point do you say, it's modern, it's done, this is what I think the system needs to be at for me to be happy owning it? So a few different things that are good to consider are, once the system is modernized, how does that affect the iteration speed for maintainers? If I want to make a change into the system, how much effort do I have to put in to accomplish something very trivial? If I'm changing a one-line thing, does that mean I have to spend 2 weeks of my time before I can release it and know that it works? Or can I do it faster and have a tighter loop for making changes? You made a change, great. How do you validate that the change works? Do you have a good ecosystem for testing and knowing that your system is actually stable, or is it deployed to production and see who comes and yells at me with this new release? I'm not saying we don't do that, but some people might, I don't know. How much effort does it take for new people to get started with your system? So as I mentioned, it's a lot of blood, sweat, and tears for you to feel like a power user of the system. That's not a great pattern, right? You don't want people to feel like they have to climb a mountain before they can do anything with your system. Not everyone needs to be a hardcore athlete in order to participate in the world that you're building. And also, as you make changes and reach this end state, are you going to leave behind a lot of people who are the power users of your system? You will often discover that power users are great in that they know a lot of things about the system. They are also more often than not pretty jaded about the system because they've fought with it for years. And one of the things that you'll want to do is gain their trust. You want them to feel good about you owning the system, especially if you are not yourself a power user of the system, as was our case. So you want to make sure whatever you are proposing as the end state has everyone on board. The people who are using this day and night, and the people who are going to be using this as they join the company or join the organization. And of course, walk before you can jump and jump before you can leap. So you define the end state. You're not going to go out tomorrow and rip the rug out from underneath everyone and say, great, and in one sprint, we're going to change this entire system altogether. That's not going to work for a number of reasons, obviously. So one good thing to do is break out your project at that point into high-level milestones. As what does the modernization mean at each stage? And within those milestones, you should have very small iterative chunks that you can easily test so that you know with confidence as you're progressing that things are moving in the right direction. And again, define the end state, right? Define when it's done. So for that, you need to figure out what actually matters for me to say I'm done. What are the things that need to exist in this end state for me to be happy? What parts of the system do you keep? What do you remove? We'll get into that. And again, just have good testing throughout the process as you go along. So yeah, you want to paint a picture, and you have to do it over an existing canvas. So someone else has already painted a potentially beautiful or not picture, and that's the canvas that you're working with. So probably a good idea to not waste good parts, right? There might be really solid foundation for the system, and you don't really need to fight with that. So you should figure out what are the parts that are good to keep versus what are the parts that don't belong at all. So don't belong at all might be this is not a good pattern for the code to follow, or this makes my life harder as a developer. It might also be that there's now actually dead code in your system that no one is using. And that code might be very difficult for you to maintain or migrate. So before you start fighting with all the parts of the system, figure out what are the parts that people actually care about. What's being used versus something that was developed years ago and is completely irrelevant now, but would require a lot of time for you to take ownership and change. And also, you have to do this without spilling any paint all over the floor, which is to say that the system still has to work in production all the while that you're making changes. People are going to be using it day in and day out, and they're not going to wait for you to say, I'm going to kill this and bring it up later once we're more stable, right? Cool. So with that, we'll talk about the work that we did for automating a lot of the different parts of the puzzle. Yeah. So I'm going to hand it over to Marius, who will talk about some of the work that we did with respect to figuring out what parts require people and what parts don't.
So the system that we inherited also had very little in the way of sort of automatic testing. So the first thing we did was we said, okay, well, this thing runs in production. Production is a test. It's a bad test, but it is a test. So it's like, what's the minimal piece of production that I can harvest so that I can build a representative sample of how the system works, and then just run this thing all the time, so that you can sort of have a good estimate of like, I've changed the thing, it hasn't broken, it's maybe fine, and that way you can start building up a set of sort of faithful, reasonably good unit tests fairly quickly by basically just running real production workloads on it, just in a way that it doesn't target that it doesn't actually produce real production data. So it's like, harvest what you have in production. It's extremely useful. The stuff runs already, and you can probably talk to people and find actual use case patterns of how the stuff works. And then by doing so, you will also gain some empathy for your users, like how the hell they're using the system, and you're going to understand why things are the way they are. So we did this. So we built our big sort of smoke test system. It runs all the time. Cool, we're happy now. Except we're not. There's loads of code that's like really outdated there. And as we mentioned before, there's lots of it. So how do you do this? You can't do this yourself. So we stood on a lot of sort of open source technologies to go and do large scale sort of code refactorings. So find all of these tools that already exist that will modernize code and sort of do things. We had like large systems that would just run lots of just standard rip grep and grep over code bases to just move pieces around and sort of change them and make them more modern. And in that way, you can automatically run these things as the mainline of the code, which is still in production, progresses. So you can sort of, I make all these changes to my code, but it doesn't have to be simultaneous. You will find that if you have lots of code here, just working in a sort of Git side branch doesn't really work. You have to be able to sort of continuously reapply a lot of the stuff that you're doing up until you get to a point where you're actually at something that can actually run a lot of these test suites and things like that in its sort of semi-post-modernized state. So we used a lot of standard things, so PyModernize and PyUpgrade. And then at some point, you hit an edge. So now you need to start building your own tools to help yourself automate this migration. We're a pretty small team. So when we started this, it was basically us. There's slightly more now, but it's still not a huge, it's not a huge team. So going through like tens of thousands of lines of code, it's just, or tens of thousands of files of code, it's just not going to happen. So we built a little thing, which we don't have a great name for, which we call structure-aware refactoring. So you can basically write a couple of tools that can sort of automatically turn something like this, which is old-style pandas, into slightly less old-style pandas. And the way we've structured this is you can decompose all Python code into an AST, and then you can do sort of pattern matching on this code, and you can find bits and you can move them forward. So this is an example of what one of these things looks like. So it's got a sort of little pattern, you can find it, and you can find this thing, and then you've got a replacer, and you can change things out. So we're working on open sourcing this, and we think this would be a sort of a generally useful tool for the community to use in sort of helping them to maintain both sort of external packages as well as internal libraries that sort of move forward rapidly. So we built it on top of like a lot of pre-existing great tech. So we didn't really write a lot of this. We just stood on the shoulders of giants. And so with a little bit of Googling, you can find a lot of really great stuff that you can just mostly sort of cobble together into a really great little tool. So, and as a last resort, it's like, you know, edge cases are everywhere, right? So we've done all this automation so that we can sort of move large hunks of the code forward automatically in a very structured way. But there's always that special case. There's that thing that works. And, you know, you need to make the value assessment of, look, this thing is strange. There's like 3 of them. Should I go and build a tool to automatically move them, or do I just fix them by hand, right? So it's the standard Python ethos of special cases. It's like, they're not special enough to break the rules, but let's be practical about it. So there's always the allure that's like, I'm modernizing this thing. I can fix it. Like there's this awful thing there. You can just see it, and you've got the design in your head, and it's like, this will be great. It's like, don't. Just step back a bit, look at the problems. Like, there's a lot of other stuff that you have to get done first. And, you know, you don't, at this point, you don't even necessarily know like what's actually running. So there's a lot more pieces that you can rather build to maintain the stability of your system. So you need to be comfortable in this process of actually treating portions of your system as a black box, which is a very, very uncomfortable situation for a developer to be in, especially when you can see the code. But it's not easy software. So treating it as a black box and saying, it's like, well, I know what goes in, and I have these test suites, and I know what comes out. So just build more of those, and then you can start understanding a lot more behavior of your system whilst you internally build confidence and understanding and sort of lifting the veil over your black box. So instrument everything. So the more you know about the runtime behavior of your system and how things flow and the states of them, the more informed you're going to be, and the better result you're ultimately going to have in your new world. And you can keep that instrumentation because your users are going to use this in the future.
Yeah, so again, very important thing, you have to remember your users. Empathy goes both ways, which is to say that users have pains, so do maintainers. And you cannot just as a maintainer look at the code and try to think of what will make my life easier. The end goal has to be what will make the system usable for everyone involved, right? So you have to think about what do people need from this and what do I need from this, which is to say, if you're going to propose telling your users, I'm not going to develop any new features that you want from the system for, say, 6 months because I'm going to spend the time gutting the foundations, that's all well and good. But then at some point, you have to pay back that debt that you're taking on from them, right? Which is what we had to do. When we took ownership of the system, we started talking to our stakeholders, and we realized that people have literal spreadsheets where they ranked features that they want as critical, high, low, whatever. And they gave it to us and said, this is what we need for our side of the business. This is the timeline, and this is why it's really important. Please make this happen. And we looked at it and we realized there's literally no way that we can make these changes in any sort of way that will make us feel like we can do this safely without breaking everything with every commit that we make. So at some point we made the decision of talking to our users and telling them, we're sorry, you will see nothing from us that you care about for the next 6-ish months. But we promise that after that, we'll give you a lot of the things that you want much faster than we can now. As you can imagine, they were not super thrilled about this. We did get some amount of pushback, but in the end, we stood firm and we said, you have to understand what life is like on this side of the fence as well. And we can promise you that you will see the rewards, if not immediately, then over time. But as you do that, you have to give them that end deadline of, this is by when I can confidently say that we will pivot to making the feature improvements that you want from us. You cannot just tell them, we need to make the system modern, we don't know how long it's going to take, but we'll tell you when we're done, because people are just going to, at some point, stop caring and stop listening to you. And either they'll lose faith in the system, or they'll lose faith in you as developers, and maybe the business will make a decision that you guys are not the best people to be owning this piece of tech. Maybe we'll hand it off to someone else. So as you do this, even though you can tell them we're not going to make the changes that you want, you still have to kind of give them a little something along the way. So pick tiny improvements that you can make in the system safely as you do your large-scale migrations, so that you can at least make their lives iteratively better, if not exponentially better. So welcome to the world of tomorrow, right? Once you're done, once the system is modernized, now you have to pay back that debt, as I mentioned. So as you think of what are the features that I can build out, pick things that are super impactful. Pick things that most people will see benefit from, or some people will see really exponential benefits from. Don't pick tiny feature improvements that you feel like you can make safely because you kind of understand that part of the system. You have to then prioritize the needs of your users, even if it means going into some of those black boxes a little bit. Hopefully you'll have built enough of an ecosystem where you have some good testing and visibility to know that the changes you're making are safe at that point. But you have to pick things that people will look at as the end result and go, all right, that was worth my time and trusting you. And you have to open the gates. You have to let people contribute to that system as well. You will find that probably those power users have been making more changes than anyone else in the system. And they're probably still going to want to do that. And you can't just say, all right, we've now changed what the system looks like. We're the maintainers. You can't make changes anymore. A better approach is figure out what the SLA for a contribution looks like. So define that up front, and then tell users this is the new pattern that we have to follow, regardless of the fact that you might have made 100 commits into this repository over the last 6 months. Now there's this new world, and this is a pattern. If you disagree with it, let's talk about what parts you disagree with, but this is now a contribution workflow that has to be followed for any new changes that you want to contribute, so that you can feel good as maintainers about taking on responsibility, and users can still feel like I can make my life better and don't have to wait for you to prioritize a feature that I want from the system. Don't rinse and repeat, which is to say, great, you spent this time modernizing the system. Do not rest on your laurels and say, all right, this is now fine. No one needs to worry about the system. Let's move on to building the next great piece of tech, right? You have to make sure that once you bring it up to parity, you actually maintain it. Otherwise, really, in PyData 2020, 2 other people from Flatiron are going to be standing here and telling you about the great work they did in migrating this legacy system. So with that, we will hand it over to you to ask any questions.
10 minutes for questions.
Or not. I'm afraid.
I have a question. I'm wondering, the fact that this is a data pipeline, like internal tool, what makes that, does that make it more complicated, less complicated than other internal tooling? I was wondering if you could talk a little bit about sort of the idiosyncrasies of data-related software.
Cool. I can start.
Sure.
Yeah, so really, it's not so much about the data part, it is more about the fact that we are kind of like a platform team, right? Which means that the users of our system are really, for the most part, most of the engineering within the company, which means that there's a lot of very diverse use cases. So any changes that you want to make has to kind of be evaluated against potentially the needs of 150, 200 different engineers. So the biggest challenge really was, what changes can we make that some people are not going to veto immediately because it's just so against their use case that we can't make it safely, or we can't do it without abandoning a chunk of the business. For us, that's always like the biggest question. As the team that sits in the middle, at the base layer, what can we do that will not topple the house that's built on top of this?
Yeah. The other part is that a lot of pipelines, of data pipeline sort of code in various enterprises frequently has a relatively poor to no testing. Which is true of most code, unfortunately, but so the part that makes it a lot more sort of tricky is that your output of knowing that things are still correct is a little bit more complicated than just does it run. Does it still produce the actual correct data set as an output? So there's a little bit more validation that needs to go into that of sort of comparing prior with current and etc. So there's some sort of temporal aspects of this that you need to take into account as well.
Can you walk through an actual use case? Your system got this data to start with, performed transformation X, Y, and Z, ended up with data that looked like that.
Can you repeat the question?
Yeah. The question was, can we give an example of a use case of the system? Yeah, so I guess in what context would an example be helpful? Is it something about how the system works, or something about what we felt was legacy and needed modernizing?
What did your users do with the system?
Sure.
What was this actually doing for them?
Sure. So as I mentioned, it's used to build all of our data products. So what that really means is that people write different parts of the ETL pipeline. So really everything from extract this data from this source to apply this business logic using Python or SQL or whatever else to put this data in this location for me to use to run a different pipeline on top of it. So
can you walk through a concrete use case where these things were actually done to a piece of data?
you want to give, any pipeline, I guess, but I don't know what we can.
Sure. So at Flatiron Health, we do a lot of work with medical data. Because we work very heavily with EHR data. So these data sets are sensitive, some of them are large, they're all generally fairly complicated. So a lot of what our analysts and sort of engineers are very skilled at is being able to sort of understand a lot of the medical value of data and really know the true sort of like business, and they bring a lot of sort of domain expertise. So they tend to work in a lot of these sort of smallish files that know how to like transform and sort of normalize, say, a drug name of some kind. A drug has numerous names because the medical space is weird. You'd like to build a data set that has normalized all of these things to base ingredients.
Okay.
Right? So that pipeline is important. So you've now taken a list of, say, all the drugs that a patient was given, you've normalized them into base components. The output of that pipeline then is then used by loads of other downstream things. So
it's published as a result name?
Yeah, it's published as a thing.
Okay.
And then downstream pieces can use this. So obviously, you need to be very careful when these pipelines get very deep. And in our cases, our pipelines are extremely deep. And lots of these pipelines are fairly small individually, but the aggregate behavior of them becomes very complex.
Right. As you can expect, there's hundreds of different, thousands of different pipelines. Most of them use some common base nodes that run across all of them. So as you're making changes to how the system generates output, any change that you make to a file could potentially affect thousands of other things that you're building downstream. So,
were you making changes to the framework that pipelines ran in?
Yes.
Or the pipelines themselves that are running on your system?
Yes.
Separate code bases?
So the question was, are we making changes to the system that is running the pipelines or the pipelines themselves? The answer is a little bit of both. For the most part, we own the system that runs the pipelines, but the two are so coupled, you can't really draw a clean line across the board. So what it really ended up meaning was we wanted to change a lot of the parts of how things are being run, but also we needed to provide users a path to get to the new world of what their pipelines need to look like to play nice with the system. So a lot of the work that we ended up doing, like the ASU refactor part that Marius talked about, ran over people's pipeline code and brought their code up to a new modern standard. Yes?
It's kind of a random, sort of maybe more business side question, but I was just wondering, you guys said you inherited this and hadn't really worked with the product under the hood before. I'm in a similar situation. Do you guys have to actively provide product support while you're doing all of this?
Yep.
Yes, we do. Yes, so the decision of us owning it was kind of like a weird one in a sense, because obviously you probably don't want people who've not really worked with the system very deeply to take ownership. But at the same time, the team was centered around solving problems of data tooling at the company. You can't kind of have a team that does that without having it own the thing that does most of the data tooling at the company. So yes, we still had to provide support for it as we went along. Thankfully, at that time, we did have a product manager on the team who used to be a data insights engineer, who was one of the power users of the system. So when questions came up on how do I do X in the system, and the two of us looked at each other and said, he kind of answered them. But yes, there were occasionally times when we basically had to dig into things ourselves to be able to answer questions for people who were maybe not as familiar with it.
Did you build in time in your timelines that you gave your stakeholders for that?
Yes and no. Yes, in that we actually held office hours regularly for people to come to us for questions with the system. And before we started this giant refactor, we spent about 3 to 6-ish months improving the documentation around it. So we took all the existing docs that were there, we kind of cleaned them all up to get rid of the ones that didn't make sense anymore, wrote some new ones just to clarify some basic workflows, and then partnered with other engineers who understood the system to contribute more docs into the ecosystem to make it easier for new folks to get started. All right, I believe we are at time, so thank you all for attending.